This section is called rational expressions. A rational expression or a fractional expression is anything that can be written as something divided by something, where the two somethings are algebraic expressions. So x plus 1 divided by x minus 1, or this one here, x squared plus 1 divided by x cubed minus 2x squared minus 1, and so on. Rational expressions is where both the top and the bottom are polynomials. Remember, polynomials are things like these things here. So these would be rational expressions. This one here would just be a fractional expression, because this top part here is not a polynomial. Now, we can simplify rational expressions, and it's quite important to be able to do so, especially if you go on to calculus, by finding out if there's a factor of the top which is also a factor of the bottom. In this example here, there's a factor of the top and a factor of the bottom that are the same. That factor is 3. 3 goes into 6 and 3 goes into 9. And if you divide top and bottom by 3, you'll get 2 over 3. And we can do a similar kind of thing for this expression here. It's not immediately apparent, but if you try factorizing the top and factorizing the bottom, factorizing the top, x squared minus 4, that's one of those difference of squares examples. It gives you x plus 2 times x minus 2 on the top. And then it might take you a little bit longer to factorize the bottom, but you're looking for two numbers that multiply to give negative 6 and add to give negative 1. Those two numbers are negative 3 and 2. And then when you get to this stage here, the factorized version, you'll spot that there's an x plus 2 on the top and an x plus 2 on the bottom, which is they're both factors of the top and the bottom. Since they're factors of the top and bottom, it's possible then to erase those, right? To eventually get rid of the x plus 2 on the top and the x plus 2 on the bottom. And if you do that, what you should get is this. Now there's another example down here. I want you to try and do the same here. You can try example 2 and example 3. Pause the video, and then when you're done, come back and check your answers. Okay, for the example 2, if you factorize this expression here, you should get something that looks like this. And if you factorize this expression here, top and bottom, you should get something that looks like this. And you'll notice that there's an x plus 5 on the top, an x plus 5 on the bottom. There's also an x minus 3 on the top, and we have x minus 3 as a factor of x minus 3 squared. And so then we can simplify like this. And you can see that the x plus 5 and the x plus 5 have cancelled out, and one of the x plus 3's on the top is cancelled out with the x plus 3 on the bottom. X minus 3 on the bottom. In example 3, if you factorize, you should get something like this, and then cancel out things that are both on the top and the bottom. We should end up with this. If you want to add fractions together, the important thing to remember is you need the same denominator. We need the same thing on the bottom here as we have here. And unfortunately, we don't have that in this example. So the thing to do is to try factorizing first. Now, if you factorize both of those expressions, you get this expression here. Now you'll notice that 2x minus 1 is a factor of both of the denominators here. And so we don't need to just to multiply these two things together. The LCD is actually this. Right? Now if you think about that, this goes into this, and this divides into this. So if we want to write this expression here with this as the denominator. So we're going to have to multiply the bottom by x plus 3 in order to get this. And if we multiply the bottom by x plus 3, we've got to multiply the top by x plus 3. So that's going to look like this. You'll see that the x plus 2 has been multiplied by x plus 3. And if you look at the second fraction, this fraction here, what do we have to do to x plus 3 times 2x minus 1 in order to get this on the bottom? We've got to multiply this by x. So we had to multiply the top by x. So we have here x minus 4 times x. X minus 4 had to be multiplied by x. And now that we've got the same denominator, we can just add those two things on the top. It's a little bit tricky because first of all you've got to multiply out the brackets, but then you can just gather things together to get this expression here. Now if you have what's called a compound fraction, that means something that has fractions on top and fractions on bottom, so we've got fractions within fractions, then the best way to try and simplify that is to find the lowest common denominator of the fractions that are inside the fraction. In this case here, the lowest common denominator of this and this is 6. And then you multiply the top by 6 and the bottom by 6. And you'll see that down here. We've multiplied this by 6, right? Each term by 6. And each term by 6 on the bottom. Now we can do the same thing when we've got algebraic compound fractions. And you can see here we've got 2y on the bottom here and 2x on the bottom there. A common denominator for that is 2xy. Right, so we find 2xy as our common denominator, so we've got to multiply the top by 2xy and the bottom by 2xy. And if we do that, what we should get looks like this. You'll notice that, for example, the 2 and the y cancel out with the 2 and the y here. If you then just multiply things out, so we're still left with an x there, and we've got to multiply that by the x, for example. The next step would be to simplify like this, and you should take some time to verify this for yourself, and then sometimes it's possible then to simplify that a little bit more after that, and because sometimes there's a factor on the top that's also a factor on the bottom. In this case, that's not the case. Okay, on page 3, I'd like you to try example 6 for yourself, just bearing in mind that the LCD of x plus h and of x is x times x plus h. So you're going to have to multiply the top and bottom by x times x plus h. So try that now, pause the video, and then come back when you've finished example 6 to check. Okay. You have to multiply top and bottom by x times x plus h, and this is what that looks like. I strongly advise actually writing it like it's written here. Don't try to take shortcuts, because often if you try to take shortcuts and try to go straight to the next step, you miss things, you forget about some of these values. Here it's easy to see that you had to cross out the x and the x, that we had to cross out the x plus h and the x plus h. Now if we simplify that, what we should get is this. Another step. Multiply out the brackets on the top, we get this. And you'll notice then that the 3x and the 3x cancel out, leaving us with this. And the next step after that is that something very nice happens. The h and the h both cancel out. This is something, if you go on to do calculus, which happens very, very often. And that's one of the reasons we do this this topic, rational expressions. And then finally, we should have this. Now, one of the final thing I think that we've got to do in this section is to make sure that we're able to rationalize denominators. We've done this in a previous section, so we can do it fairly quickly. You'll remember that if you need to rationalize the denominator, get the denominator to be a nice integer number, for example, we had to multiply top and bottom by the same as, in this example, the same as the bottom, square root of 3. So if you want to rationalize the denominator of this thing, you've got to multiply the bottom by the square root of 5. Okay, and if we do that, it looks like this. The top is just going to be 3 root 5, but the bottom, if you do the square root of 5 times the square root of 5, that's 5. And then you're going to have 5 times 2 in there. So we have this, 2 times 5, which finally gives us this. And the other thing that we use for rationalizing denominators, I'll bring this up so you can see better, is using this difference of squares formula here. Because we can make something that's like this, 2 plus root 5, into an integer by multiplying 2 plus root 5 by 2 minus root 5. Now that will seem a little bit strange the first time you've done it. This is what thing is called the conjugate of this. So if it's 2 plus root 5, you have to multiply by 2 minus root 5. If it's 2 minus root 5, you have to multiply by 2 plus root 5. But again, you have to do the same thing to the top as you do to the bottom. You'll notice, and this is the interesting thing, that when you do this times this, you get 2 squared minus root 5 squared. Root 5 squared is 5, so it's 4 minus 5, which is minus 1. So that gives you the nice number on the bottom. So try example 8 now. Now it might have been quite difficult for you to think of the conjugate of this expression here, but the conjugate of that expression is right here. Instead of being 2 root 3 minus root 5, it's 2 root 3 plus root 5. And then, if you multiply top and bottom by that, well, the top should be easy. You just do 7 times each of these values here. But the bottom part, okay, this is again that difference of squares thing that we have. It's going to be 2 root 3 all squared, and it's going to be root 5 all squared. And that's what's given us this expression here. But if you do 2 root 3 squared, that's 2 squared is going to be 4. Root 3 squared is going to be 3. So the next step is it's going to be like this. And you'll notice now that we've got something that's nice on the bottom. That's going to be an integer on the bottom there. simplify that like this. And then there's one extra step. You'll notice that 7 is a factor of the bottom and of the top. So we can just simplify by dividing top and bottom by 7, and we get this.